Grignard reagent. The reactants for Grignard reagent formations are alkyl or aryl halide and magnesium with the presence of dry ether. So, for example, we have one haloalkane reacts with magnesium in the presence of dry ether. The alkyl or aryl halide, the alkyl aryl group, will bind with magnesium delta plus. So the alkyl group delta minus, the magnesium delta plus. So make sure magnesium bond to R, not to this side of X. The Mg must bond to R and the Mg also bond to the halogen. So this is Grignard reagent. So in methyl iodide, 1 carbon, 3 hydrogen, 1 iodine reacts with magnesiums in the presence of dry ether in dry ether. So this magnesium form bond with the carbon, and the magnesium also has bond with iodine. So this is the Grignard reagent. Grignard reagent can be used for the formation of alkanes, alcohols, and carboxylic acid. Alkanes can be formed when Grignard reagent reacts with water, and alcohol can be formed when the Grignard reagent reacts with carbonyl and acidified water. Finally, carboxylic acid can be formed using Grignard reagent reacts with carbon dioxide and acidified water. So this is the synthesis of alkanes using Grignard reagent. So first, formation of Grignard reagent, haloalkane react with magnesium in dry ether, and R group bond to MgX. This is the Grignard reagent. So the Grignard reagent must react with water to form alkane and salt. The electrons between R and MgX bonding electron is used to form bond with hydrogen and water. So these two electrons between H and OH will be transferred to O, making this O has one more lone pair. So the OH-O lone pair will be used to form bond with MgX. That's the salt product. So this is the example. This is the haloalkane reacts with magnesium in dry ether. This is the formation of Grignard reagent. So make sure Mg bond to the carbon and the halogen, not C bond Br bond Mg, but the Mg must be bonded to the carbon and to the Br. So this is a Grignard reagent, CMgBr. In order to form alkane, the Grignard reagent must react with water. So you just remove the MgBr, replace it with hydrogen. So it has 1, 2, 3, 4, 5, 6 carbon. Same 6 carbon. It's just like replacing MgBr with H. Formation of alcohols. Initially, we must form the Grignard reagent. from haloalkane and magnesium in dry ether. So the Grignard reagent reacts with carbonyl functional group with different R group in acidified water to form different class of alcohol. Similar to haloalkane, alcohol also have different classes. So primary alcohol is alcohol which attach to carbon, which is primary. Secondary alcohol, functional group hydroxyl attached to carbon, which is secondary carbon. And tertiary alcohol, the hydroxyl group attached to the tertiary carbon. So to form primary alcohol, we must use carbonyl compound with no R group at all. The reactant must be the reactant of the carbonyl compound must have no R group at all. In the presence of acidified water, then the product will be primary alcohol. Notice that new Cr bond is formed. So we have carbonyl compound with no R group. So break this one double bond O, form C single bond R. R is the R from Grignard reagent. So R from Grignard reagent is the R from the haloalkane. It's this R. For the formation of secondary alcohol, the carbonyl compound must have only one R group. Then you can form secondary alcohol because one R group from the carbonyl compound, another one R group from Grignard reagent. So two R group in total. That's why the product is secondary alcohol. For the formation of tertiary alcohol, 3 R group in total, we must use carbonyl compound with 2 R groups. So 2 R groups from carbonyl compound, 1 R group from Grignard reagent, 3 R groups in total in tertiary alcohol. That's the formation of alcohol. This is the example. So 1 R group from Grignard reagent, formaldehyde no R group at all, so the product must be primary alcohol because 1 R group in total, so primary alcohol. Note that the carbon which attached to hydroxyl group must be the carbon that attached to double bond O. It must be the same carbon. This carbon double bond O, this carbon single bond O must be the same carbon. Don't change the position of the hydroxyl group. Finally, formation of carboxylic acid. Carboxylic acid can be formed when we have Grignard reagent reacts with carbon dioxide in acidified water. So the product is carboxylic acid, C double bond O. So this C double bond O will be the carbon which has double bond O and the carbon which has hydroxyl group. It must be this carbon, and the R group will attach to this carbon, the C double bond O carbon. For example, so this is tertiary haloalkane, Grignard reagent with 3 alkyl groups. So reacts with carbon dioxide in acidified water. The product must be the carbon C double bond O. This carbon must be COOH carbon. So it's like you're replacing MgCl with carboxylic acid functional group. Carboxyl functional group replaces MgCl. That's how you write the chemical reaction for formation of carboxylic acid using Grignard reagent. Thank you.